A light year, sometimes written light year or light year, is a unit of length used in astronomy, though it is sometimes mistaken for a unit of time. It is equal to just under 10 trillion kilometers. As defined by the International Astronomical Union, a light year is the distance that light travels in vacuum in 1 Julian year. The light year is most often used when expressing distances to stars and other distances on a galactic scale, especially in non-specialist and popular science publications. The unit usually used in professional astrometry is the parsec. Definitions: as defined by the IAU, the light year is the product of the Julian year and the speed of light. Both these values are included in the IAU system of astronomical constants, used since 1984. From this the following conversions can be derived. Before 1984, the tropical year and a measured speed of light were included in the IAU system of astronomical constants, used from 1968 to 1983. The product of Simon Newcomb's J1900.0 mean tropical year of 31,556,925.9747 ephemeris seconds and a speed of light of 299,792.5 a kilometre per second produced a light year of 9.460530 a. 10:15 am found in several modern sources was probably derived from an old source such as C. W. Allen's 1973 Astrophysical Quantities reference work, which was updated in 2000. Other high-precision values are not derived from a coherent IAU system. A value of 9.4605362007 a. 10:15 am found in some modern sources is the product of a mean Gregorian year and the defined speed of light. Another value, 9.4605284005 a. 10:15 am, is the product of the J1900.0 mean tropical year and the defined speed of light. History: the light year unit appeared a few years after the first successful measurement of the distance to a star other than our Sun, by Friedrich Bessel in 1838. The star was 61 Cygni, and he used a 6.2-inch heliometer designed by Joseph von Fraunhofer. The largest unit for expressing distances across space at the time was the astronomical unit, equal to the radius of the Earth's orbit. In those terms, trigonometric calculations based on 61 Cygni's parallax of 0.314 arcseconds, showed the distance to the star to be 660,000 astronomical units. Bessel added that light employs 10.3 years to traverse this distance. He recognized that his readers would enjoy the mental picture of the approximate transit time for light, but he refrained from using the light year as a unit. He may have resented expressing distances in light years because it would deteriorate the accuracy of his parallax data due to multiplying with the uncertain parameter of the speed of light. The speed of light was not yet precisely known in 1838. Its value changed in 1849 and 1862. It was not yet considered to be a fundamental constant of nature, and the propagation of light through the ether or space was still enigmatic. The light year unit appeared, however, in 1851 in a German popular astronomical article by The paradox of a distance unit name ending on year was explained by Euler by comparing it to a hiking road hour. A contemporary German popular astronomical book also noticed that light year is an odd name. In 1868 an English journal labeled the light year as a unit used by the Germans. Eddington called the light year an inconvenient and irrelevant unit, which had sometimes crept from popular use into technical investigations. Although modern astronomers often prefer to use a parsec, light years are also popularly used to gauge the expanses of interstellar and intergalactic space. Distances in light years: distances measured in fractions of a light year usually involve objects within a star system. Distances measured in light years include distances between nearby stars, such as those in the same spiral arm or globular cluster. 1 kilolight-year, abbreviated KLI, is 1,000 light-years. Kilolight-years are typically used to measure distances between parts of a galaxy. 1 megalight-year, abbreviated MLI, is 1 million light-years. Megalight-years are typically used to measure distances between neighboring galaxies and galaxy clusters. 1 gigalight-year, abbreviation GLI, is 1 billion light-years one of the largest distance measures used. Gigalight-years are typically used to measure distances to supragalactic structures, including quasars and the Sloan Great Wall. Related units, other units of length can similarly be formed by multiplying units of time by the speed of light. For example, the light second, useful in astronomy, telecommunications and relativistic physics, is exactly 299,792,458 meters or 1/31,557,600 of a light year. Units such as the light minute, light hour and light day are sometimes used in popular science publications. The light month, roughly 1/12 of a light year, is also used occasionally for approximate measures. The Hayden Planetarium specifies the light month more precisely as 30 days of light travel time. Light travels approximately 1 foot in a nanosecond. The term light foot is sometimes used as an informal measure of time. See also: Einstein protocol, 1 petameter, orders of magnitude, Hubble length, astronomical units. Notes. References.